China has just taken one of its most ambitious steps toward the moon. On August 15, 2025, at the Wenchang spaceport on Hainan Island, the nation's space engineers carried out a dramatic full-scale static fire test of their upcoming lunar rocket, the Long March 10. For the first time, 7 YF-100K kerosene engines roared together on a real launch pad, generating nearly 1,000 tons of thrust. That's almost 3 times the power of China's current Long March 5. And with it, China confirmed that its engines could ignite in sync, run at multiple power levels, and deliver the stability needed to send humans beyond low Earth orbit. What makes this test unique is not only its raw power, but the way it was conducted. Traditional test stands simply couldn't handle the stress of so many engines firing together. Instead, engineers used the actual launch pad, turning the trial into both an engine test and a rehearsal for future flights. Alongside engine data, they evaluated new heat-resistant coatings, advanced fault detection systems, and the reliability of the cluster design. All of this feeds directly into China's ambitions to place astronauts on the moon before 2030. The Long March 10 itself is a giant, standing 92 meters tall with a core and 2 strap-on boosters. It will light 21 engines at liftoff, 7 in the core and 7 on each booster. This clustered power is designed to send about 27 tons, roughly the weight of a small house, toward the moon. That puts it in the same performance league as NASA's Space Launch System, though with a very different approach. China plans a dual launch mission, one rocket carrying the crew vehicle called Mengzhou and another carrying the lander named Lanyu. In lunar orbit, the two will dock, allowing astronauts to transfer and descend to the surface. Historically, this marks the culmination of decades of rocket research. China's Long March 5 enabled robotic lunar sample returns, but it lacked the power for crewed missions. The Long March 10 closes that gap. Previous milestones included a 3-engine test in 2024 and Hydrolox upper stage trials. This latest 7-engine trial, however, is a leap into the scale required for crew-rated lunar transport. Compared to global competitors, Long March 10 sits in an interesting niche. It won't rival SpaceX's Starship in sheer size or reusability, but its thrust and payload are on par with NASA's SLS Block 1, designed for a very specific goal of getting Chinese astronauts onto the moon by 2030. Unlike Falcon Heavy, which is partially reusable but has a smaller translunar payload, the Long March 10 is built purely for deep space human exploration. And while Starship chases the vision of a single massive, fully reusable spacecraft, China is focusing on a 2-launch lunar rendezvous strategy with an expendable heavy lifter. Strategically, this test was more than just a technical check. It demonstrated that China has the infrastructure, the clustered engine capability, and the determination to handle the immense forces needed for lunar exploration. Beyond the first landing, the rocket is central to plans for the International Lunar Research Station, a permanent base near the moon's south pole, by 2035. Alongside this, a sister variant known as Long March 10A is being developed with partial reusability for Earth orbit missions using a novel tether capture recovery method instead of landing legs. In short, this test wasn't just a fire on the ground, it was the fire that may ignite a new era of human exploration led by China. With the engines proven in sync and the path to the moon laid out, the dream of a Chinese astronaut planting footsteps on the lunar surface is closer than ever. If you found this deep dive into China's lunar ambitions informative, make sure to hit the like button, subscribe for more updates on space and technology, and let us know your thoughts in the comments below.